Welcome to Pioneer Career. Today we are going to discuss factor theory. How many factors a number has? Let's start with 1. 1 is the only number that has one factor. Only 1. Then any prime number. Prime number has only 2 factors. 1 and the number itself. Let's example 2, 3, 5. These are prime numbers. So factors of 2, 1 and 2. Factors of 3, 1 and 3. Factors of 5, 1 and 5. So factors of prime numbers are only 2, 1 and the prime number itself. Now factors of a composite number. If I ask you to write down all the factors of 120, how will you write down? Factors of 120. So let's note it down. 1, 2, we all know 3 is also a factor. 4, 5, 6, 8, 10, 12. After that, students have a bit problem writing down the factors, because till 10 or 12 we can find out whether the number is divisible by 120 or not, but after that there is a problem. So try to find out the two factors whose multiplication gives you the number itself. Here in this case 10 into 12 is equal to 120. That means next factor is 8 into 15, 120. Then 6 into 20, 120. 5 into 24, 120. 4 into 30, 120. 3 into 40, 120. 2 into 60, 120. 1 into 120, 120. Hence in this way we can list down the factors. But if number is bigger, then we cannot apply this formula. Then we have to apply another formula. Let us suppose a number n, and we need to find out the number of factors of n. So write down n in the standard format. I mean a to the power p, b to the power q, c to the power r, and so on. Here a, b and c are prime numbers. Prime numbers. P, q and r, these are integers, positive integers. So write down 120 in its prime factors. We all know 120 is equal to 8 into 15. So we can write it down as 2q into 3 to the power 1 into 5 to the power 1. Once you have written down your number in this format, the number of factors of this n is given by a formula p plus 1 into q plus 1 into r plus 1. Hence number of factors of 120 is equal to 3 plus 1 into 1 plus 1 into 1 plus 1. That is 4 into 2 into 2. 16 factors. If we count, we have 16 factors of 120. Now, so in this way we can find out the number of factors. But how to find out whether a number is a perfect square or not? So again the same thing, write down your number in a standard format. N is a perfect square only when each of p, q and r is even number. Each of them is even number. If a single one of them is not even number, then n will not be a perfect square. If n is a perfect cube, perfect square. If n is a perfect cube, then each of p, q and r must be multiple of 3. If n is a perfect square as well as perfect cube, that means each of them p, q and r must be a multiple of 2 as well as 3, that means must be a multiple of 6. Now let us see the concept behind this formula. We all have seen that 120 is equal to 2 cube into 3 to the power 1 into 5 to the power 1, and number of factors is given by 3 plus 1 into 1 plus 1 into 1 plus 1. What is the reason behind this? What is the reason behind this formula? P plus 1 into q plus 1 into r plus 1. A factor of 120 must be in form of 2 to the power something into 3 to the power something into 5 to the power something. 2 to the power something. How many values here we can put? We can put either here 0 or 1 or 2 or 3. That means we can put here 3 plus 1, 4 values. How many values we can put 3 to the power? We can put 3 to the power 0 or 3 to the power 1, or we can put 2 values here, 1 plus 1 How many values of 5 to the power anything we can put? We can either put 0 or 1. That means again 2 values. So how many ways we can fill up this place is 4 ways. How many ways we can fill up this place is 1 plus 1, 2 ways. How many ways we can fill up this place is 1 plus 1, 2 ways. So total number of factors is given by 4 into 2 into 2, that is 16. Now let's discuss another concept related to factor theory. Question is, in how many ways you can write down 120 as a product of two of its co-prime factors? Co-prime factors means HCF of two factors should be 1. Here for 120 we can write down 1 into 120, HCF of 1 and 120 is 1. 2 and 60 HCF is 2, so we cannot take this pair. But 3 and 40 HCF is 1 and 3 into 40 120. 4 into 30, 4 and 30 HCF is 2, so we can't take this pair. 5 and 24 and 8 and 15. So in 4 ways we can write down 120 as a product of two of its factors, two of its co-prime factors. If n is in the standard format, a to the power p, b to the power q, c to the power r, where a, b, c are prime factors. In this case, let us suppose n is the number of prime factors. Like in the case of 120, we have 1, 2, 3, 3 prime factors. Once we have written down n in its standard format, then number of ways in which we can write down this number n as a product of two of its co-prime factors is given by a formula 2 to the power n minus 1. Hence look at this number 120. We have n equal to 3 because number of prime factors is equal to 3. Hence in how many ways we can write down 120 as a product of two of its co-prime factors is given by 2 to the power 3 minus 1 or 2 to the power 2 or in 4 ways. Let's take another example. Let's take another number 840. 840 we can write down in prime factor form as 2 cube into 3 to the power 1 into 5 to the power 1 into 7 to the power 1. Here how many prime factors we have used? We have used here 4 prime factors. Hence n equal to 4. So if the question is in how many ways you can write down 840 as a product of two of its co-prime factors is given by 2 to the power 4 minus 1 or 2 cube or 8 ways. So total 8 ways we can write down 840 as a product of two of its co-prime factors. Now next concept is to find the sum of all factors of a number. Once you have write down n in its standard format, the sum of all the factors of n is given by a formula a to the power p plus 1 minus 1 by a minus 1 into b to the power q plus 1 minus 1 by b minus 1 into c to the power r plus 1 minus 1 by c minus 1. It gives us sum of all the factors of number n. So if we need to find out sum of all the factors of 120, that is given by 2 to the power 3 plus 1 minus 1 by 2 minus 1 into 3 to the power 1 plus 1 minus 1 by 3 minus 1 into 5 to the power 1 plus 1 minus 1 by 5 minus 1. So by using this formula we can find out sum of all the factors of a number.